Welcome, boys and girls, to our Form 3 topic, binomial expansion. This is Form 3, Lesson 1. Okay? So, I want us to understand the word binomial expansion. Binomial means two terms. So we are dealing with expansion of two terms, binomial. Mono inakuwaga moja, one, mono, by two. So these are example of binomials. In each bracket, there are two terms. So this is what stands for bi, two terms. Then when we expand, we are able to get the coefficients. When we expand this, it is to power 1. So it remains A plus B. So what is the coefficient of A? 1. What is the coefficient of B? 1. How many times do I have? 2. Suppose I have A plus B squared. A plus B to power 2. Do you remember how you can do it often? The first term squared, A squared. If I want to get the second term, I do multiply the inside, the elements, which is A times B. I get AB, then double. So in my expansion, I have 2AB. Then I also square the last term to get B squared. So what is the expansion? A squared plus 2AB plus B squared. The coefficient of the first term of my expansion is 1. The coefficient of the second term of my expansion is 2. And the coefficient of the third term and last term is 1, because we had B squared. So if I extract the coefficient, we get 1, 2, 1. A plus B to power 3. A plus B to power 3. Okay? I can do it here just to help you, because I know you can't get it often. It will be A plus B to power 3 will be A to power 3 plus 3A B plus 3A B plus, I can do it. You have to do it step by step. What is your step by step? You have to do A plus B in bracket A squared plus 2B plus 2AB plus B squared. You have to do this. You have to go through this before you come here. But that is something small you can do. So, what is the coefficient of the first term? 1. Second term, 3. Third term, 3. Last term, 1. How many terms in total? 1, 2, 3, 4. So 4 terms. Now, that is what our mind can do first. And even in exam, you can do it. But now, suppose you are asked, what is A? A plus B to power 8. A plus B to power 8. that requires a lot of multiplication. Okay, a lot of multiplication. But all this has been simplified in the table. So I do not need to cram the table, but how to apply the coefficients in my expansion. They are written binomial coefficients. What I have here, these are binomial coefficients. They help you build up the expansion. They are not expansion by themselves, but they are components of expansion. So when I'm given like a plus b in bracket to power 8 to expand up to maybe b to power 3, or to expand 4 terms or 5 terms or 3 terms, you can easily get the coefficients in the table. They are already done here. Okay, so let us get this example. Let us get that example and we see how to apply. But before I get to that, even in the event you don't have a mathematical table, how do you survive? You have to see the relationship that is being built. The first one is simple because you have a plus b to power 1. It is just a plus b. That is the expansion. Then the second one, a plus b in a bracket squared. The coefficients are 1, 2, 1. Now that we have done up to power 3 and we got the expansion, I don't want this column now. I don't want this column, but basically you should know it is 2 plus 1, they are 3. 1 plus 1, 2 terms. 2 plus 1, 3 terms. 3 plus 1, 4 terms. So if I ask you, how many terms are there if you expand a plus b in bracket to power 8? A plus b in bracket to power 8. How many terms? When you expand, how many pieces will be there? The answer will be that power 8 plus 1, which gives you 9. There will be 9 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9. We don't call them pieces. The proper language in mathematics is term. So there will be 9 terms. Now, the focus is, I don't have a mathematical table. How do I survive? You have to build the sequence. The foundation is already here. So you have to add courses on your foundation. How do you do that? Look at the sequence. You can easily get to the middle. This one is the middle of the 2. This is the middle of the 2. And you will always end up with 1. Okay? So, I get any 2 figures. I get here 4. This is 6. This is 4. But you will always end up with 1. Start with 1, end up with 1. Okay? So can you try to fix here? Try to fix. Start with the middles. When you are given any 2, you can get the middle. Okay. For those who have tried, check with my answer. Here I will write 5, 10, 10, 5. Always end up with 1. Okay? So, you can't get beyond power 8 in your level. In the secondary level, there are always limits. After this level, when you continue with maths, you will still get more mathematics. But normally, we put you into good foundation. So, Without mathematical table, a student should be comfortable to generate Pascal's triangle. This is the work of Pascal, who came up with this kind of observation. Okay, so you can get. Now back to our question, we want to do one example. So we've done a plus b to power 4, and here a plus b to power 5. So I want us to do an example to expand 1 plus x to power 5 up to 2x to power 3. Okay? We are given such a scenario. We expand 1 plus x in bracket to power 5 up to x to power 3. So when you are told up to, it means they don't need the entire expansion. You have been given the limit, how far you should go in your expansion. So this would be advice for you. Let us focus our camera. I can focus it there. 1, start with coefficients. So this is 5. Okay? This is 5. So the coefficients are 1, 5, 10, 10. With the time you will know why I stopped there. Okay? So coefficient is that. Better still, we can use a simple technique of V. A simple technique of V. That. And you draw the line coming down, going up. This is first term. This is second term. You use a letter V. Okay? So what do I mean here? The first letter goes down, the powers decrease, and the second term, the powers go up. So I come and write here 1. This one here. The 1 in black. Okay? The 1 in black. And then I will use X in red. When I use these colors to make you follow. So I'm saying 1, the power will decrease from the highest power. So what do I mean here? It will be 1 to power 5, decrease by 1. 1 to power 4, decrease by 1. 1 to power 3, decrease by 1. 1 to power 2. So let us do everything. Let us expand this. And then we shall make a conclusion from there. We have 1 there. 1 to power 1, 1 to power 0. Maybe that would make sense. You can see it decreases from the highest power you have. 5, 4, 3, 2, 1, 0. This second term, which is x, the powers are going to increase from minimum to maximum. Minimum to maximum. So what do I mean? Minimum is 0. Then 1, 2, 3, 4, 5. So I want you to get this right. We were told to expand up to x to power 3. So if you master this technique, if you understand this technique, you will not waste your time doing everything. There is no try and error in this lesson. We are not doing try and error. We have to develop the right skills. So see, these three pieces, they will help you understand up to what extent you are supposed to go. I had written up to x to power 3. So you can see up to x to power 3. So when I say x to power 3, how many terms are they? 1, 2, 3, 4. So I can tell you up to 4 terms or up to x to a given power. You must synchronize the language. One of the things that makes students fail is inability to interpret what is required. So if you don't, and you know it is exam, and exam is about separating those who know and those who do not know. So you must get the right skill, develop them. I said up to x to power 3. So when you start with the coefficient, one would have started with x up to x to power 3. Start with x in red. Up to 4 terms. You can start with coefficient, come first term, second term. So when he says up to x to power 3, the first thing, start sorting out up to what extent you will do. For me, I've shown you everything so that you yourself can synchronize up to 4th term, up to x to power 3. So after this, what do? You get what we call product. Product of each line. Product of each line. 1 times 1 times x to power 0 is 1. Okay? Product plus 5 times 1 times x. It becomes 5x. Okay? Then 10 times 1 times x squared. What does it give us? 10x squared. So we are not on camera, we focus. I will repeat. Now you get product of each line. Product of each line. Product of each line. Okay? 1 times this 1. X to power 0 is 1. So 1 times 1 times 1 is 1. Then come to this. 5 times 1 times x is 5x. Come to this. 10 times 1 times x squared is 10x squared. You move on. Plus 10 times 1 times x to power 3. 10x to power 3. We move on. Plus 5x to power 4. And then plus x to power 5. That is 1 times 1 times x to power 5. So this is our expansion. Okay, this is our expansion. The trick comes to students when you have a negative sign. When you have a negative sign, it becomes tricky. But if you maintain my approach, you cannot have problem. You cannot have problem. Even if you put this part, you compute it. So if I had -x, it would be -x, -x, negative x, negative x, negative x, negative x. Then you put a bracket and then the powers remain the same. So when you are getting the final products, the sum of the products, where you have an even power, you will have positive. Where it is odd, it will be negative. So it is important to know what I'm doing here. In conclusion, I'm saying binomial expansion means what? Expansion of two terms. Okay? Bi means two. So there are two terms or two elements in a bracket. You are required to expand to give us the expansion form. What do you need? You need to understand, one, that there are coefficients that have already been given in the table. Then number two, the first term, the powers will decrease from highest to lowest. They decrease by 1 in each subsequent term. Number three, the powers of the second term increase from 0 onwards, each time an increment of 1. Number four, you get the product of each vertical line, and that will be your expansion. Note that sometimes they give you a big power, but they tell you up to. Understand the language of up to. There are two forms. They'll tell you up to the fourth term. Now that one is very easy to get. When they tell you up to the second term to power n, second term to power n, for example, x to power n, then you are dealing with n plus 1 terms. Subscribe, you get the second lesson. In binomial expansion, it will be this, and then the next one will be just computation. Tell your friend there is something we have to learn. Keep each one busy at home. Don't sleep. Exam can come anytime. Bye-bye.